notes, okay? So like I said, 13.3 has the ability to be a very difficult unit for many, many people, okay? So that's why I want to make sure I give it the time of day to really let it sink in. I am not assigning your Math Excel homework for this week on 13.3 yet because we haven't learned the whole lesson. It'll become enabled on Monday. So that's why homework this weekend is just focusing in on your air test practice assignment 21 and 25 through 31. Notice you're skipping questions. That's because you're skipping probability questions because we're not all the way down this chapter yet. The other thing that has become available to you on Math Excel, though, is the other bonus assignment. The other air test bonus assignment features transformations. The other topic you learned about in middle school that we're just crossing our fingers and hoping that you remember before the air test. Does that make sense? Okay. Here we go. The first thing about 13.3 that I need you to still remember is the fundamental counting principle. And didn't we already talk about that? Just a little bit. We talked about how many ways there are for you to wear an outfit. We took the number of pants that I had, the number of shirts that I had, and I multiplied those numbers. So the example that the textbook brings us is we have 4 entrees and 6 drinks. In total, if I multiply 4 times 6, it gives me 24 different ways I could choose my lunch. The reason why the fundamental counting principle works is thanks to tree diagrams. And if you remember this week, I showed you the tree diagram about the ways to flip 3 coins. Remember that tree diagram? So that's the reason why it works. Tree diagrams we don't use anymore. We just simply use the fundamental counting principle, but we will return to tree diagrams when we're dealing with other probability. Yes, Dan?
Can you read what the last few words say?
There are m times n or 2 times 3 equals 6 possible outfits.
No, I mean, I can't read it.
Why don't we just look at it on Schoology later on, okay? All right, so a deli offers a lunch special. If you choose one from each of the following types of sandwiches, side items, and drink choices, how many different lunch specials are possible, okay? So first thing I need to figure out is how many numbers I'm going to multiply by. So I need to figure out, I have sandwiches, it's something I have to choose from. Side items, it's something I have to choose from. Drinks are something that I have to choose from. So what I'm going to do is give myself 3 placeholders because there are 3 items for me to choose. Therefore, there are going to be 3 numbers for me to multiply by. So now I got to look in the first category. The first category being sandwiches. How many sandwich choices do I have? Very good. Why have I heard the number 7 appear in my life today? Why do you think somebody would have told me there are 7 sandwich choices? Henry?
Oh, because it says ham and turkey.
Ham and turkey.
But
Very common issue. Very common issue. So beware of those issues. What about side items?
I thought you put
4. Very good. Now, I've also heard this before, actually on a test question at my old school. Potato, salad.
No.
Dead serious. You laugh, but there will be one person in every class who will do a potato salad.
Since whenever?
I'm
It
serious.
doesn't even have and in the middle.
I know, but it happens. How many drink choices?
5.
All right, so by the fundamental counting principle, we are going to multiply all those numbers. So 6 times 4 is 24. 24 times 5 is 120. So there are 120 different ways for me to select my lunch. Yes, you're right. So here's your turn. You're going to generate passwords. Your password has 1 letter followed by 2 digits. So aka you have 3 characters, okay? This is the reason why I made sure you knew how many letters there were in the alphabet and what was considered a digit. I'll give you a moment here to answer this question. I'm not trying to be tricky. I'm not trying to be tricky.
Trying to be tricky with garden salad.
Fruit salad?
Just
Ah!
eat an entire garden, guys.
I'm serious about the potato salad, though, guys. I really am.
I don't
All right, you ready to take your answer on this one? Unfortunately, it's happened to more than one student in my life. 2,600, yes? All right, let me ask you this clarifying question. So in this one, it specifically said the same digit cannot be used more than, it can be used more than once. Had I said it can't be used more than once, aka no repeating digits, what numbers would I have multiplied then?
10 times 9.
Very good. 10 times 9, because we would have decreased the amount of available digits. All right, so leading into a very, not as tricky, but it will get tricky when I introduce something else, concept is a concept about a permutation is. A permutation is a way of arranging a certain amount of items where the order in which I arrange them is very, very important. For example, this is an example of a permutation. Caitlin wins first place. Moira wins second place. Nathan won third place. That is one arrangement. But me saying Nathan won first, Caitlin won second, and Moira won third, that's different. Even though it involves the same people, they won different prizes, didn't they? Make sense? That is an example of a permutation, okay? Permutations bring up the concept of a factorial. Did I talk to your class about factorials this week? Are they getting kind of super excited in math? Is an exclamation point appearing? When I see 4 factorial, that really means 4 times 3 times 2 times 1. If I just represent it as n factorial, I take the number n and I multiply it by everything less than n by going in a sequential amount of taking away 1. So n times n minus 1, then take away 1 from that, so we have n minus 2, all the way down to the number 1. Now here's an important fact. 0 factorial is defined to be equal to 1. It's just a fact that in math we kind of just have to accept. The only semi-acceptable explanation I've ever been able to find on Google is because, well, how many ways are there to arrange nothing? One. Just one way. That's the only semi-acceptable way of doing it. And I'm like, I'm not totally in love with the explanation, but it's all I could find.
Well, wouldn't there be no ways to arrange nothing if you can't arrange anything?
Well, now you're getting too fancy. You
Is it
download 8
two?
songs on your music player. If you play the songs using the random shuffle option, how many different ways can the sequence of songs be played? So we have to play a song first, play a song second, play a song third, fourth, fifth, sixth, seventh, and eighth. So I have 8.
64.
All right, y'all really just steal my thunder in this class. All right, so how many ways are there for the first song we've chosen? 8 ways. How many ways for the second song we've chosen? Then, then,
2, 3, 2.
and then as Nathan so slyly said, rather than us writing out all those numbers and wasting a bunch of our time, what could I have simply written? 8 factorial, okay? Now, 8 factorial is something that you can type into your calculator. My friends who have a red calculator, you're first going to type in an 8. Actually, so are my TI Inspire friends. Then, hidden on the probability button on the red calculator, if you press the PRB, you'll see an exclamation point for you to touch. On the bottom right-hand side of your TI Inspire, you actually have the ability to have an exclamation mark as well as a question mark, apparently.
Yeah.
But you just type in 8 factorial, and you should get a number around, I don't know.
40,320.
So what that means is there's 40,320 ways of arranging these songs. You type in 8 with an exclamation mark next to it.
Oh, that's it?
Yes.
I like how you're screaming at your calculator and numbers.
8! 8!
Yeah.
All right, your turn.
Oh, I found it.
Your turn.
Oh my god.
Done.
I don't
Nice.
remember.
Okay.
Really remember.
All right.
Am I supposed to?
You ready to check it?
Wait.
No.
Wait, hold on. Am I supposed
Well, that's a really long number.
Yeah, wait. Okay.
All right, let's check it. So you should have gotten 479,001,600 ways.
Yeah.
Awesome.
That's a lot.
So permutations sometimes get a little bit more picky. They're a little bit more to it because I don't always want to listen to all 8 songs. Sometimes I don't want to listen to 3 songs. So in that situation, I wouldn't need all 8 of these spaces, would I? If I want to listen to 3, I only need
3.
3 spaces. So all I would do is 8 times 7 times 6. Now the more fancy the situation, the more complicated it becomes. Therefore, I might want a formula.
Hold on.
So my formula is going to produce the exact same thing. Notation is very important because I will ask you know these formulas. Okay? NPR. That means permutation. N represents the total number of items I am picking from. R represents how many items I am picking. The equation that we have for it is n factorial divided by the quantity n minus r. First you do that, then factorial of that. So we know that if I have 8 songs and I want to pick 3 to listen to, we already know it's just be 8 times 7 times 6. But let's see why that's true. So in the top I would have done 8 factorial because 8 would have been my n. And on the bottom I would have had 8 minus 3, which simplifies to 5. So we have 8 factorial divided by 5 factorial. And if I start to expand out the factorials, look at that. Things cancel out. And what am I left with? 8 times 7 times 6. Does that make sense?
Do that? All of that?
Well-
Or we just like
Let me show you a different way, okay? So the environmental club is electing a president, a vice president, and a treasurer. This is an example of a permutation because me being the president is way different than me being the vice president, right?
I mean
Yeah, it is. So we have to first figure out in this question, what is my n? How many total people do I have to pick from? Very good. So you have 10 pick, because it's a permutation. How many people am I picking? 3. Very good. So 10 pick 3. So now to show my work in the top, we have 10 factorial divided by n minus r, so that would be 10 minus 3 factorial. If I start to simplify things, the bottom is going to become, well, 10 minus 3 is 7, so 7 factorial. Now I'm going to show my work and expand it out. 10 factorial is really 10 times 9 times 8 times, you know what, I'm going to get lazy here. Instead of writing 7 times 6 times 5 times 4 times 3 times 2 times 1, I'm just going to write 7 factorial. Why did I choose in this particular problem just to write 7 factorial?
because you can
Because
just
it gets
do
the
that.
rest of the way that the 7 had.
Well, because it's on the bottom, right?
Yeah, because it's right there and
So you
it'll.
can just get rid of
You've
it.
already
Oh
got
my
it.
god, so I can just cancel them out. And then what am I left with?
720.
10 times 9 times 8, which is simply 720. Yes, you could treat this just like a fundamental counting principle problem, but you also need to be able to show me your work. Okay? Here's your question.
Okay.
Dan says he feels good writing the exclamation points. He's like, yes. I hope we all feel that way.
Do we have to write like ways? Like if we don't put ways after everything, we're gonna.
I'm not going to get that picky.
Okay. Thank you.
You're welcome. I got bigger fish to fry in this unit. Technically I could, but you know what, I'm feeling kind of nice today.
Thank you. Such nice.
Alright. You ready to check your answer? Okay. So I'm hoping you did 12 pick 3, which should have simplified to 1,320, yes? Alright, so here's the reason why people don't like permutations. Because they confuse them with combinations. I know, see? Right. Anyways, combinations is an arrangement of items where order is not important. For example, hey, Nathan and Caitlin and Moira, you want to go to lunch? Okay. Actually, wait, Caitlin, Moira, and Nathan, you want to go to lunch?
Yeah.
Did it matter which way
Wait,
I
no,
said it, or are they all going to lunch with me? They're still all going to lunch with
No,
me.
you put me at the end of the list, so I'm in a salty mood.
Anyways, because I'm not assigning them roles, it's not a permutation. Okay, here's another good example. You know that thing at your locker? What's that thing called? Combination lock. It lied to you. It's actually a permutation lock. And here's why it's a permutation lock. If my code is 1, 2, 3, only 1, 2, 3 is going to work, right?
Yeah, but you can answer
If it was called a combination block, not only would 1, 2, 3 work,
3, 2,
but 3, 2, 1 would work, and 2,
2,
3, 1 would work. So it lied to you this whole time in your life. It is a permutation lock.
But it's a combination of numbers.
Lies and slander. Notation. NCR. N still represents the number you have things to choose from. C, I'm going to always say choose. R is how many things you're choosing. The formula is different. You have n factorial still on the top, but now you have r factorial times n minus r factorial. Okay? So it's a little bit more complicated. Suppose that you choose 4 books to read on summer vacation from a reading list of 12 books. How many different combinations, now this question was nice, it explicitly said combinations in the question, of the books are possible? What is my N going to be? Very good, 12. How many books am I choosing to read? I have 12 books. I'm choosing to read 4 books. So according to the formula, we have 12 factorial on the top. On the bottom, we have r factorial, which is 4 factorial. And then we have n minus r factorial, so we're going to have 12 minus 4 factorial. So now I'm just going to start to simplify it just a tiny bit, okay? Well, what's 12 minus 4?
8.
How about 8, guys? 12 minus
said
4 is 8.
eight.
Sorry.
So what I'm going to do is on the top, I'm just going to expand 12 factorial to being 12 times 11 times 10 times 9 times 8 factorial, because it's helpful on the bottom, because what happens? It cancels out, okay? So now I have 12 times 11 times 10 times 9 on the top, and on the bottom I have 4 factorial, which is 4 times 3 times 2 times 1. Now, hey, wait a minute. What's 4 times 3? If I got 12 on the top and 12 on the bottom. So what I'm really left with is 11 times 10 times 9 over 2. But hey, wait a minute. What's 10 divided by 2? So all I'm really left with is 11 times 5 times 9.
Can we type this in our calculator?
Yeah. What's 11 times 5 times 9?
No, I meant like that
55 times
equation right there.
9.
Yeah, what's 55 times 9?
It's 495.
495. Okay? We good?
Yeah.
Here is the very last problem.
Wait. What's the difference
Between what?
between combination oil terms?
Okay, so let's read about it. It says a service club is 8 freshmen. 5 of the freshmen are to be on the cleanup crew. This is a combination. Because I did not say on the cleanup crew, you're scrubbing the deck, you're sweeping the floors, you're doing the dishes. I wasn't picky. I just said, hey, you're on the cleanup crew. So does it matter that I'm telling you, you're on the cleanup crew, you're on the cleanup crew, you're on the cleanup crew, because guess what? It sucks. It's not going to be on the cleanup crew, right? Doesn't matter what order I say it in, so that's a combination. And that's why this is a very tricky topic. You have to be able to figure out, is it a permutation or a combination? And that's why we're going to be making sure we practice it Monday. Okay? So we got our last got it. And on Monday, I'll teach you how to do it in your calculator.
Wow.
Look at that. Some of your faces were like, why didn't you just teach us this now?
And
Kind of. I'll even shortcut it, I guess, more. Ah. So fun fact, 8th period, you got the farthest in this lesson of all 4 classes.
Really?
You did. You want to take your answer on this one?
Yeah, sure.
All right, let's check it.
Done, but sure. Why the heck not?
56 ways. Yay.
I was doing the math right then.
What's-
Slow.
It's okay, Dan. You were doing it right, so guess what? I believe in you. Other fun fact, guess what? I just recorded you.
What?
We
were the
recording.
Oh, why? We've
You have
never
to
been
get our
recording.
permission to put
Why
that
are
in
you
public.
amazing?
I didn't record